Before I left the university, we started a large project looking at the effect of climate change on crop growth, and I was particularly interested in the implications in terms of crop nutrition. We grew crops in an enhanced carbon dioxide, at an enhanced level of carbon dioxide in the atmosphere, and tried to simulate what the 2050 carbon dioxide content would be, and then looked at different scenarios in terms of temperature and water availability. What we saw from that work was that the high carbon dioxide actually enhanced production of the crop. Carbon dioxide is an important input into photosynthesis. More photosynthesis, more crop growth, more yield. But at the same time, that requires a little bit more water, and it depends whether the crop is temperature stressed. And water availability and temperature both come along with the changes in carbon dioxide concentration. So the complicated issue becomes, what will the water regime and the temperature regime be in association with those elevated carbon dioxide? But generally we'd think that there might be up to a 25% increase in grain production, grain yield for a wheat crop with enhanced carbon dioxide, if the water availability and the temperatures are still at current levels. What that means in nutrition sense, if you drill down into the nutrition side, 25% more yield means 25% more nutrient requirement. So there's more nitrogen required, more phosphorus, more potassium. All of those nutrients will be required to be replaced with the higher crop yield. We looked at some of the dynamics of phosphorus in the soil, found there wasn't a lot of change in terms of phosphorus cycling due to high carbon dioxide. We looked at the effect of high carbon dioxide on nitrogen fixation, and it enhances the growth of legumes more than it enhances the growth of cereals, non-legumes, simply because the cereals are usually nitrogen limited, whereas the legumes fix their own nitrogen, and so they are able to be stimulated more. But that doesn't necessarily mean you get a net bigger nitrogen benefit from the enhanced legume, because you actually harvest a lot of the nitrogen in the grain. So the interaction is that nitrogen availability, there will be an increased demand for nitrogen in our future cropping systems under high carbon dioxide, and we'll need to address that through efficient and effective use of nitrogen, maybe changing the sources. We've just published some work looking at the effect of ammonium supply versus nitrate supply, two different forms of nitrogen, and we found that ammonium is much more effective at maintaining plant nitrogen concentrations than nitrate, and there are some biochemical reasons for that. So there are some clues we've got from our work about nitrogen management, but certainly whenever you increase yield, whether it's due to carbon dioxide or early sowing or whatever strategy agronomically you use, if you remove more nutrient, you have to replace more nutrient. There's no such thing as a free lunch in nutrition. The other implication of climate change and the work we did was that crop yields will change. Where it becomes hotter, crop yields will become increase less than in a cooler environment. The crops will be able to compensate a little better, but the yield potentials will still be higher in the higher rainfall zone. And we're already seeing changes in our production systems due to the climate changes that we've already experienced. I mean, climate change isn't something that's going to happen soon. It's been happening now for 30 or 40 or 50 years. And the signals have been clear about that. So we've seen a movement of our production systems to the south with high rainfall, movement into the high rainfall zones. more reliable production in those zones. It's come along with the good agronomy practices that have come to support those high rainfall zones, such as improved nitrogen management, better crop varieties. But climate change is going to push the cereal growth areas, cereal belt areas, further towards the coast, further into the current high rainfall zones. The work we did through what was called the AgFace program, the Australian Grains Free Air Carbon Dioxide Enrichment Project, was pretty clear that you would get a 25% increase in wheat grain yield in the Wimmera region at the current levels of water availability and with the current temperature regimes. Hotter temperature regimes means the yields will decline. So the combination of those gives you the uncertainty about what will really happen into the future. In some ways, we will adapt our agronomic systems to deal with that. It might be early sowing, it might be different varieties. We're continually adapting our cropping system, and carbon dioxide and climate change is just another pressure in terms of adaptation. And climate change is happening, has happened, and will continue to happen. And growers and researchers will need to continually look for ways to enhance their adaptation of their management systems to address those risks that come with high temperature and low water availability. So with climate change, with the pressures on farming, with the resource availability, there becomes increasing pressure on using resources such as fertilisers. Nitrogen fertilisers rely very much on gas for their production. Phosphorus fertilisers are mined, as are potassium fertilisers, and transported and manufactured. Whether we can do without those depends on what the world population food demand is and what sorts of food the world will demand. The world maintains its needs for grains, for human food and also for animal food. There's no alternative but to keep using some of our resources to produce those fertilisers. The alternative is to make the decision about which half of the world doesn't get the food that we're producing. And that's a pretty difficult situation, because it's half the world food supply depends on the availability and the use of synthetic mineral fertilisers.